This tutorial is going to be using version 0.11 of the RayTK library. It's using some features that are new to this version, so make sure to download either this version or a newer one. I'll include a link in the description. Down at the bottom here, there's this tox file. Download that and then drop that into your project. So now that the library is loaded, I'm going to create a RayMarch render and add a null at the end so we can see what's coming out of it. And I'm going to set the resolution on this to something that's narrow and tall, just so that we can have an easier way to view this on the side. So I'm going to go with 500 by 1000, and we'll change that later, but for now I'm going to use that as a way to preview things. So I'm going to split this pane left and right. I'm going to set the display flag on this top here, so it's showing the background. And I'm now going to switch this panel type to top viewer and resize that down about there. And then in this network panel, I'm going to turn off background tops, which makes it a little bit easier to see the network. Now that we have our renderer set up, I'm going to create a torus SDF and connect that to the first input here. And there you can see the torus showing up in the render there. Now on the torus, I'm going to change the axis parameter, which is new in version 0.11. Change that to Z, so it's kind of facing the camera there. And instead of using the default camera that's built into the renderer, I'm going to create a look at camera and then connect that to the second input, the camera input. There is a small bug in this version where it doesn't necessarily recognize when that connection is made. And so the workaround for that is just to go into this network and then pop out of it. I am still working on figuring out why that is happening, but for now, that workaround does what we need. I'm going to move the camera back a little bit so we can see the whole shape there. So now we've got our basic scene set up. I'm going to start modifying the geometry. I'm going to create a twist operator and insert that between the torus and the RayMarch renderer. And if I increase the amount parameter here up to, let's say, increase it up to about 2. You can see it's starting to deform the shape. Now this other parameter, the shift parameter, offsets the twisting along the axis that's being twisted around. So you can see here we are twisting around the x-axis, and this is basically shifting the twist along that axis, which is effectively the same thing as rotating the shape. And I'm going to add another one after that, and this one is going to use the y-axis and insert that between that first twist and the renderer, and increase the amount here up to about 2 as well, and then apply that shift there. So you can see now that we've got these 2 twist operators chained like this, the shift effect on that first one ends up having a little bit more of an interesting effect. So to take advantage of that, I'm gonna add some animation to those parameters. I'm gonna do that by creating an LFO chop and rename that channel to twist X and decrease the frequency there to something like that. And create a null at the end here. And then I'm going to take this channel and drop it onto the shift parameter here. So it's now applying that sine wave pattern to the shift there. And I'm going to, so I'm now thinking that I like that pattern somewhat, but I'd rather have kind of a continuous motion. So instead of using an LFO, I'm going to start with a constant. Again, set the name to twist X, and then add a speed chop after that. So what this is going to do is continually increase or decrease at whatever rate is being passed into it. So if you set this here to a positive value, it starts increasing. You can see it's kind of a continuous thing. So now I'm gonna connect this to the null instead. And this is why nulls are useful. It's easy to swap out different sources of data for that without having to reconnect all the things that might be mapped to. I'm going to delete this LFO and clean that up a little. Now I'm going to copy and paste this whole chain here and rename this to twist Y. Now this we could use this as a way to apply a similar animation to the second twist, but because of how this speed and constant works, you can actually just add a second channel in here and change that to a different value, and we now have two different values in there, so we don't need the second chain at all. Going to take this second channel here and drag that onto the shift of this one. And I'm going to decrease the amount on this to about 0.5, and then this one, just keep it at I don't know, 0.8. And that amount on the twist is how intensely it twists around that axis, which ends up meaning if we were to lock this here and turn this one off for now, you can see that it is at higher numbers, it twists more for a shorter distance along that axis, and lower numbers it does it at a larger scale. So I'm gonna undo that, go back to this, and make sure that's switched back on. So we've now got a shape that's moving around, and it will just continuously move, and this speed chop approach is a good way to have values that just kind of continuously go in some direction forever, and you can get some kind of infinite variations of the combinations of the two different values. Not actually infinite, but close to infinite, by having them have different speeds, so they will only overlap occasionally. And I'm now going to focus on the post-processing and rendering aspect of this. I'm going to take advantage of a new feature that was added in 0.11, or rather it was in the previous version, but was not stable. I'm going to create a render select here, drag that onto the output op setting there, and pick the step count option and attach a null here so we can see what's coming out of that. Right now, what's coming out of that is nothing because the step count setting in this renderer is not yet activated. So on the renderer in the outputs tab, you need to make sure to find enable step output and switch that on. So you can now see we're getting something coming out of there, but it doesn't necessarily look like a useful image. Now, if you look at it really closely, you can see kind of the outline of the shape a little bit in there. That's because the values that are in this step count output buffer it's packing a couple of different pieces of data into each channel of the output. If you turn on this display pixel values option or hit that D shortcut and take a look here, you can see that there are some values in there, but the red channel seems to always be stuck at 1. And this is because the renderer is using 8-bit fixed output. So if you middle mouse on this, you can see that the pixel format here is 8-bit fixed, which means that the values can only ever go between 0 and 1. And a lot of the time that's enough, but for when you're kind of trying to pull other types of data that aren't strictly the visual output, or even if you want a greater color range out of that, you need to change the pixel format in here. And this again is another feature that was added in 0.11. So right now it's using use input, which is effectively the same as 8-bit fixed. It's now going to change it to 32-bit float RGBA. So now if we look in here, you can see that the values for that red channel are really large, 33, 40, and so on. And that green one seems to always be somewhere between that 0 and 1 range. So as a way of looking at those different channels, I'm going to create a reorder and I'm going to set these all to green and take a look there. Okay, so this is just looking at, it's copying the green channel to all 4 channels, so we can just view that one. And if we set the alpha to just constant 1, you can see it a little bit better there. So the step count output represents how many times the ray had to step forward in order to, as it was passing through the scene, checking at each point whether it is hitting a shape. This is kind of the core of how ray marching works. For each pixel, it casts out a ray. It goes from some camera point through, in a particular direction, and at each point it looks and sees how far away that point is from all of the shapes in the scene. And it knows that because that's the closest distance to that point, that it can move at least that far and know that it won't hit anything yet. So when it gets closer to a surface, that distance is smaller, so it only jumps a smaller distance, and so on. So as it gets closer and closer, at some point it gets close enough that it just considers that to have hit the surface. And that's where it picks a color based on lighting and other things. So the step count output is how many times it stepped while moving along until it hit a particular pixel. And this applies both to rays that hit a surface and to rays that don't hit a surface. So a ray that doesn't hit the surface is going to move along, and as it gets closer, it's going to, start stepping at smaller and smaller distances as it gets closer and closer, but then eventually it gets past it and it starts stepping larger distances until at some point it gets far enough that it gives up and just decides that it hasn't hit anything. So for rays that go close to a surface but don't hit it, you end up with a larger number of steps because it is doing that kind of checking and checking and checking as it passes. So the step count output here, that first channel, is just the number of steps. So you can see here, for this pixel here, it made 44 steps before it gave up and decided it hadn't hit anything. And so that's in the red channel. The green channel is that divided by the maximum number of steps it's allowed to take. So in this case, and that setting is in here, in the renderer, there's settings, maximum steps. So here it'll go up to at least 256 steps before it gives up and decides that it hasn't hit anything. So the green channel is that number of steps divided by that maximum number of steps. So you get a value that kind of ranges between 0 and 1, and that is a much more useful range to work with as an image source. So this output here is it's not quite getting all the way up to 1. In fact, it's the highest value looks like it's maybe around 0.2. And that's because it never gets close. It never gets close to the 256 steps it needs before it goes out of the scene. And so one thing that you can do with that is you could decrease the number of steps, and that will basically increase what this relative value is. So if we set that to 128, you can see that now here it's getting up to about half of that when it's hitting close to that. You could even decrease this further. But keep in mind that a lot of these parameters in the renderer are not good to animate or change rapidly. That's because a lot of them are when they change, they cause the whole shader to be rebuilt, and it does that for optimization reasons. Because it knows, it's going to be paying attention to the maximum step count in a lot of places throughout the shader. So it ends up being a little bit faster if it can kind of assume that that's always going to be the same, which means that it doesn't get passed in the way a lot of other parameters do. So if you were to try, dragging this around, you can get some frame rate drops, and this is a relatively simple scene, so it's not particularly bad here, but if you drag it around there, you can see it's dropping down to 10 frames a second, and that's on a GTX 2080. So with these render things, yeah, just gonna go back to that default. And I'm gonna keep it up at 256 because there may be cases where, you know, working on this in the future, that there may be points where rays need to go through more steps based on whatever the shape is. So instead of adjusting that there, I'm gonna adjust the value that comes out of it here using a math top. So I'm gonna connect that and I'm gonna change the range. So it looks like the highest value in here is somewhere around 0.2. So if we set that from range here to somewhere down, 0.3. So now you can see that it scales that value into a much more visible range. And I'm going to connect that to the final output here for now. Now, one potential issue with using step count like this is that you may be able to see in the image there, but if you zoom in there, you can see that it kind of, you get these hard edges like that, and this is kind of unavoidable with using step count. There is another type of output called near hit, which is similar, but we'll go into that later. But for now, we're just gonna work with it as it is. And mostly the part that we care about here is kind of the part that's right around the edge anyway, where things are a little bit smoother. So I'm gonna add a level top in here and play around with some of the settings in here to see if I can kind of isolate that a little bit better. If you increase the contrast there and decrease gamma, increase brightness somewhere in there, that gets a little bit closer to what we're looking for. So that's a pretty decent glow that will follow around the shape as it goes, and this ends up being pretty efficient. So at least on this hardware, it's getting 60 frames a second, and though that is at a relatively low resolution, but in general, step count output is just about as efficient as the regular rendering is. So I'm gonna add a null here just to that main color output here, so we can kind of look at both of them. And I'm going to like to add a little bit of a color to that's not just white. So there's a bunch of different ways of doing this. One that I like, just because of the kind of visual feedback, is to create a constant top, set the resolution down to just like one pixel, and then create a multiply, connect that up here, and make sure that fixed layer is input 1 and that extend overlay is hold, and then connect that here. So now if we change the color there, you can see that it applies that to the image at the end. So I'm gonna go with kind of a bluish white. I'm gonna add another null here and add a composite top that's going to mix these two. I'm gonna see if I can get some interesting results from that. So if you just go with something like lighter color, that actually works pretty well. You can try out different variations in here, but I think actually lighter color is about what I'm looking for. So to recap for now, what we have is a torus that's going through two twist operators. Both of those are using this shift parameter to kind of continuously move along, spin around that axis. And that's going into a renderer with a standard look at camera. And then for the output, we are looking at the step count output here using a render select with step count selected, and made sure to enable that output on the renderer here. Grabbing the green channel out of that output, which is the number of steps divided by the maximum number of steps. We're kind of scaling that into a better range, using a level to increase contrast and such, using this multiply to apply a tint to it, and then compositing that with the original. So I'm now going to try using a slightly different source of geometry instead of a torus. I'm going to create a Mobius ring SDF, which is similar to a torus, but it applies some twisting and has kind of a, instead of a round cross section, it has kind of a square, more square one. Just to take a look at the inspector here and move that in. This is what the Mobius ring looks like. We can increase the radius, change the thickness. The twist setting here is kind of how much it twists as it moves around, and you'll notice that if you're using values that are a whole number or half or 0.25 and so on, it'll be kind of a smooth continuous twist. But if you're using kind of partial fractional values, then there'll be kind of a discontinuity in it. So I'm going to use something like, even just 2 it looks good. And there's some other parameters in here we can adjust. There's thickness. There is the amount of rounding, so it kind of gives it these a little bit of a sharper edge, or a kind of more smoothed out pattern. There's also twist phase, which right now it sort of looks like it's just rotating, but if you were to switch go back to one of those partial values here, that you can see that it is kind of moving the twist around the ring as it goes. So I'm going to go back to 2 and going to change this axis to Z, and going to connect that up here. So that gets us to kind of a similar pattern, but with a little bit more of an interesting source geometry. So one thing to note here is that the nature of this shape means that the surface is more complicated, so you're going to end up with a larger number of steps as the rays move along. So the values in there are going to kind of be at a different range. And I'm going to look again to see here, as they're now kind of up 0.3 higher or so. So I'm going to increase this to like 0.45 and increase contrast a little bit there. Okay. So that looks pretty good. And like we've done with the two twist operators that follow it, we can also animate the twist phase on this one. And add another channel here, set that, and then drag this up onto twist phase here, chop reference. And try using like a small negative number there. Now, one useful thing that you can do with a setup like this that's using a constant and a speed to be able to adjust all of them at the same time, you can add a math chop in between that constant and the speed. And then on the multiply add page, you've got this multiply slider, so you can kind of slow them all down or speed them all up. And that's just kind of a quick way to be able to control all the speeds at the same time while still having kind of a different value for each one. So now I'm going to take a look at another kind of output buffer that's similar to step count, but a little bit different. So I'm going to copy and paste actually all of these nodes, the render select all the way down through the level there. Looks like I missed one of them. There we go. Drag those down there. And the render select here, we're gonna change the output buffer to near hit. And like we did with the step count output in the render, we need to make sure we turn on that setting. And so that looks a little bit similar to step count. And if we pause this and look some of these values in here, you can see that it's the green channel in this case is kind of a larger number, and the red channel is a smaller value. So I'm going to change this to look at the red. All right. Now this has it looks similar to step count because it's calculated in a similar way, but in a way that you have a little bit more control over. So where step count is just the number of times that the ray had to move along as it was going past the shape, near hit is the amount of time that ray, or amount of distance that ray spends near the shape. So and there's some settings in here in the renderer to control the behavior of that. So you can set a range. So this is how far away a ray is allowed to pass from a surface for it to be considered a near hit. And so if you increase that, you can see that it's a larger area around the surface. And there's another parameter, fade, near hit fade, which is sort of a smoothing applied to that range. So if you turn it all the way down to 0, you end up with kind of a hard edge, and this near hit kind of smooths that out a bit. There's also an option in here to use a minimum distance. So this is this is the minimum distance away from a surface that a ray has to pass to be considered a near hit. And you could use this to, if you increase the maximum range there and then increase that, you can see that it's kind of it's only applying when it's at least a certain amount of distance away from the surface, but not more than that maximum range. And then the fade is applied to that in similar ways. So one thing to note with this is if you push these settings kind of into weird ranges, you can sometimes get some kind of rendering artifacts that can be a little bit problematic. So it's important to kind of play with these ranges and make sure that like they're within a range where you're getting the look that you want without getting any strange other behaviors cropping up. And if we swap that in here, you can see that that is sort of a shell around the shape because we're using that minimum distance. If we were to switch that off, then it's kind of everything within that range. And if you decrease that range and increase the fade, then you kind of get that sort of tight glow around the surface of the shape. I'm gonna undo that and just switch back on that minimum distance. And these settings, the near hit range, the minimum distance, the near fade, these are safe to change at runtime, so these don't require the shader to rebuild, which means you can kind of animate them without having to worry about drops in frame rate. And so that's kind of a different kind of glow. I'm gonna try, so if we take a whole separate one here, let's connect this back up, and then pick a little bit of a different color there. Add another null, and add that in there. So now you have kind of the combination of both of them. And I'm gonna adjust that color a little bit to something like that. And also decrease the alpha a little bit so it's kind of a little bit more subtle. And it's worth noting that similar to using the step output, there isn't a whole lot of cost associated in terms of performance with using this. Most of the kind of cost of the rendering is kind of you already have to do in order to get the basic color output, and this is only adding a little bit on top of that. And it gives you more options to experiment with it kind of after that first render happens. So it's a little bit easier to work with than if you were to try to be doing that directly in the shader or something. So to just review, we've now got this Mobius ring SDF and 2 twists after it. All of those are being controlled by this chop, which has these 3 different speeds for the 2 twists, and then for the phase on that Mobius ring, that's going into a math, which you can use to kind of scale all of those speeds at the same time. That's going into a speed chop, so you get that continuous moving value, and then those are being applied to the twist phase here, the shift on this one, and then the shift on this one as well. That's going into the renderer using the standard look at camera, and then we've got these 2 chains here that are, this one's looking at step count and this one's looking at near hit, and scaling those, picking in this case the green channel, in this case it's the red channel that has the data that we're looking for, and then applying a tint to each of those, and then mixing that together with the original, using a composite top here with a lighter color, and then that is the final output. And just to see, turn back on the background tops and then maximize this. And I'm gonna set this resolution back to something 1920 by 1080, and then move this camera in a little bit so it feels a little bit better. And that is our scene.